Hello and welcome to a UK study guide to physics. This is the materials module and today we will be looking at the first topic of density. So density, I'm just going to give you an outline of what we're going to cover in today's topic. We're going to first look at density. What does it even mean? What's it about? We're then going to have a look at the formula for calculating density and have a look at how density is used. At the end, I will add some practice questions, which I will give you a chance to answer on your own, and then we'll show you the solutions to them afterwards. So let's take a quick look at density. What does it even mean? Density is a material property. It is calculated using an object or a sample of that object, using its mass and its volume. Density is a measure of the weight of the atoms or molecules that make it up and how closely they are packed together. You may have two objects which are of the same volume. If one feels heavier than the other, you could say that object is more dense than the lighter one. As density is a material property, it doesn't matter what shape the object is. So let's take a look at the formula. So all solid materials, and also liquid and gas too, they have a density, and it's calculated for each material using this equation below. So let's take a quick look at the first equation. So the first bit we're going to look at is this little symbol here. It looks like a P, but it is actually the Greek symbol called rho, and this is density. This is what we are trying to calculate. We're going to use mass, which we may take using a balance, and the SI unit for mass is in kilograms. We also need to measure the volume of our object or of a sample of our object. And the volume is measured in the SI unit of cubic meters. So by dividing mass in kilograms by volume in meters cubed, we can just decide that the units for density are kilograms per cubic meter. This is working out the density for just one material. Sometimes you might need to work out the density for a composite material. It is quite a straightforward equation. So this is the density of a composite, and it is simply a portion of two other materials. If it's made up of more than two, then obviously you just add more onto this. So this is the density of the first material, and this is the density of the second material. And all the X and the Y are at the front is the proportion of each. So X and Y will simply be a number between 0 and 1, and these will add up to equal 1. So if, for example, you have 10% of the first and you have 90% of the second material in a composite, then this will be 0.1 and Y will equal 0.9. So in real life, you're often looking at small objects or samples to measure density. So more likely, you will be measuring the mass in grams and the volume in cubic centimeters. When you use the same equation, you will find you get a density in grams per cubic centimetre. This is okay. It's not SI units, but it's perfectly okay to use grams per cubic centimetre as long as you are comparing the same units. So if you compare two densities, you need to make sure that they have the same units. Always check the question and convert the units to be the same at the start so you don't get confused halfway through. Okay, so let's have a look at how we might use density. One way that density is used is to determine if an object will sink or float in a liquid. Water has a density of 1 gram per cubic centimetre. If you want to know if a material is going to float or sink in water, you need to compare the density of your material with the density of water. So if the density of your material is less than 1 gram per cubic centimetre, the object will float in the water. This is because it is less dense than the water. If your density is greater than that of water, 1 gram per cubic centimetre, the object will sink in the water. That is because it is more dense than the water. Other ways you might use density is for material identification and selection. When you measure the density, it can be used to identify a material. By calculating density of a sample, you can compare it to a table of density data, and this can help you to identify which material it is made from. Also, materials for applications can often be selected because of their density. An example of this might be you are selecting a material to manufacture a car wheel. It's ideal for a car wheel to be as light as possible. So, for the same volume of car wheel, you would be looking at substituting for a material with a lower density, and that will mean it is lighter for the same volume. Okay, so now we know a little bit about density. Let's do some practice questions to see how much we know. We're going to start off with a basic question, just to see if we understand the formula. The first question is, find the density of an object with a mass of 200 kilograms and a volume of 0.07 meters cubed. If you would like to work this out for yourself, please pause the video now. And when you play, I will show you the solution. Okay, so let's figure out the answer to this question. So first of all, we're going to have a look at our knowns and our unknowns. We know that there's a mass of 200 kilograms. So we're going to put this down here. And we also know that we have a volume of 0.07 meters cubed. So we're also going to write this down here. What is it that we want to know? We want to find the density. So density is our unknown. So we need to recall the equation which we learnt earlier, and that is density equals mass divided by volume. So let's first check that we've got our units correct. Mass is in kilograms and volume is in meters cubed. So we know they are both SI units, and we will get the answer for density. So let's put these in. Mass is 200 kilograms and our volume is 0.07 cubic meters. When we divide 200 by 0.07, we get the answer of 2,857, and we know our units for density in cubic meters. So this is our answer. The density of the object is 2,857 kilograms per cubic meter. Okay, so now we're going to move on to another practice question. This is still a basic question, but it has a lot more writing in it, so we're going to have to read it properly to make sure we get out all of the knowns and unknowns. So let's first read the question. Mary would like to know the volume of a silver ring. Mary uses a scale to measure the mass of the ring. The scale reads 21 grams. If Mary knows the density of silver is 10.5 grams per cubic centimetre, what is the volume of the ring? If you would like to work this out, please pause the video, and when you come back, I will show you the solution. Okay, so let's work this out. First of all, we need to find our knowns and our unknowns. So let's read through the question. Mary would like to know the volume of a silver ring. So volume is our unknown. She uses a scale and she measures the mass at 21 grams. So we know that mass equals 21 grams. She also knows that the density of silver is 10.5 grams per cubic centimetre. So density equals 10.5 grams per cubic centimetre. So before we move on, we're just going to have a quick look at our units. The mass is in grams and the density is in grams per cubic centimetre. So we know that they're not SI units, but they're perfectly fine. Okay, so let's come to our equation. We know that density equals mass over volume. We know density and we know mass, but we want to know volume. So what we need to do is we need to make volume the subject of our equation to do our calculations. This is going to take a bit of maths gymnastics to spin the equation around. There's plenty of ways to do this, but I'm going to do it the way I find easiest. I'm first going to make mass the subject by multiplying the density by the volume. And then I'm going to get volume out by dividing the mass by the density. So now we have our equation where volume is the subject, and we can put in mass and we can put in our density to work out volume. Okay, so let's put our numbers in. So we know volume equals mass over density. We pop our numbers in. Mass is 21 grams and our density is 10.5 grams per cubic centimetre. When we calculate 21 grams divided by 10.5 grams per cubic centimetre, we come up with 2 cubic centimetres. So the answer to the question is the volume of Mary's silver ring is 2 cubic centimetres. Okay, so now we're going to move on to another practice question. This question is taking it up a level. These aren't so basic now. A solid plastic ball has a mass of 0.04 kilograms and a diameter of 4 centimeters. What is the density of the ball in units of grams per cubic centimeter? If you would like to pause the video now, you can work this out for yourself, and when you return, I will show you the solution. Okay, let's see if you got this one right. So let's first of all have a look at our knowns and our unknowns. So we know that the ball has a mass of 0.04 kilograms. So we're going to add this down here. Mass is 0.04 kilograms. And we also know that the ball has a diameter of 4 centimeters. And it asks for what is the density of the ball in units of grams per cubic centimetre? So we want to know density. It equals a question mark. And we also know that we need to answer it in grams per cubic centimetre. So let's have a look at our density equation. We know that density equals mass divided by volume. We know mass, we don't know volume, and we don't know density. So we need to use our diameter to calculate volume. And once we know the volume, we can put mass and volume into our calculation to determine the density. So let's first have a quick look at our dimensions before we carry on. The mass is in kilograms. The diameter is in centimetres. And the answer we want to get to is in grams per cubic centimetre. So what we need to do is we need to convert it. So when we convert 0.04 kilograms to grams, it equals 40 grams. To work out the volume of a ball, it'll be roughly a volume of a sphere. We need to pull out this equation. So the volume of a sphere equals 4 on 3 pi r cubed. So that's a number. We know pi. We need to know r. We haven't been given r, we've been given a diameter. So we need to change the diameter into radius. So we know that the radius of a circle or a sphere is half of the diameter. So therefore, the radius will equal 2 centimetres. Okay, so we've got our mass in grams, our diameter in centimetres, and all our units match up. When we work out the volume of the sphere, because we're using the units of centimetres cubed, it should come out in centimetres cubed. So we know we're on the right track. So let's do our calculation to work out the volume of the sphere. So it's 4 on 3 times pi times 2 centimetres cubed. And when we do our calculation, it should come out approximately 33.5 cubic centimetres. So now we know the volume, and we can put that into our equation to work out density. So let's go back to our equation. Density equals mass over volume. We know our mass from our known, which is 40 grams. And we've just calculated our volume, which is 33.5 centimetres cubed. Sorry, I'll just correct that. Okay. When we do our calculations, it comes out at 1.19 grams per cubic centimetre. Okay, so we're going to do some more practice questions, and these ones are getting a little bit more tricky. The question reads, a sample of a composite material is taken from a car bumper. The sample is approximately 10 centimetres long, 5 centimetres wide and 5 millimetres high. The bumper is made from 30% carbon fibre and 70% solid polymer. Use the table below to determine the density of the bumper sample. If you would like to pause the video now, you can work this out for yourself and come back and have a look at the solution. Okay, so let's have a look at the solution. We know from the equations at the start that to work out the density of a composite material, we need to know the proportions of the two also materials that it's made from. So we're going to call one material density 1 and the other material will have a density 2. So we're going to call material 1 our carbon fibre. And material 2 will be our polymer. We know that the carbon fibre has a proportion of 30% and our polymer has a proportion of 70%. We just need to convert these into proportions out of 1. So 30% is 30 over 100, which is the same as 0.3. For the polymer, 70% is the same as 70 over 100, which is the same as 0.7. We just need to make sure that 0.3 and 0.7 add up to 1. Okay, we also need to look at the table to have a look at the density of each material. So the density of carbon fibre from the table is 2.0, and that is in grams per cubic centimetre. The density of the polymer, reading from the table, is 1.2, and that is also in grams per cubic centimetre. So now we just need to put everything into the equation to work out what the density of our composite is. So the density of the composite equals our proportion of carbon fibre times its density. And we're going to add to that the proportion of polymer times the density of the polymer. And when we calculate it, it comes out at 1.44 grams per cubic centimetre. So the answer to the question is the density of the bumper sample is 1.44 grams per cubic centimetre. As you can see, the density of the composite is between that of the polymer and that of the carbon fibre, and it is due to the proportion of each that the composite has. Okay, so we come to our last practice question. This one is a bit tricky, not because it needs a lot of maths, but because it needs you to understand what density is about. So let's first read the question. Mary has a liquid with a density of 1.8 grams per cubic centimetre. She would like to make a raft to float on her liquid. Which material from the list below should she choose? If you would like to pause the video, you can work this out for yourself and come back for a solution. Okay, so let's work out which material she should use. So we know that Mary has a liquid with a density of 1.8 grams per cubic centimetre. So we know the density of the liquid is 1.8 grams per cubic centimetre. And we know that in order for something to float, the density of the material, it needs to be less than the density of the liquid to float. So what we need to do is go through the table and we need to see which material has a density of less than 1.8 grams per cubic centimetre. So let's have a look at the table. Aluminium has a density of 2.7, so that is greater than 1.8, so we can't use aluminium. Steel has a density of 8.1 grams per cubic centimetre. This is also too much, and it won't float on the liquid. Copper has a density of 9, and that is also too high and it won't float on the liquid. The polymer has a density of 1.2. 1.2 is less than 1.8, so therefore Mary should use the polymer. So the answer to the question, Mary should use a polymer to make a raft. Okay, so that's density complete. I hope it's helped you understand a little bit more about the material property of density. Thanks so much for watching this video, and please subscribe to make sure you see some new videos first. If you want to see anything added or you have any comments, please let me know below. Thank you.